Hello and welcome to Update by Economist. My name is Nadine Filko, and as always, I'm happy to dive 5 minutes of in-depth knowledge seeking. Before we start off and I introduce our experts, I want to say thank you to our sponsor, FEMAC. Now, as we all could see, processing can be very exciting. It's all about taste, it's about texture, it's about scalability, and also applicability for other industries. So I'm very, very happy to have 3 experts here who can tell us a lot more about all of these issues in the next 45 minutes. Welcome, Laura Pasitka, R&D Project Manager at GEA Group. Javier Zaratirgi, CEO at Cuckoo, sorry, I hope I pronounced it right now, and Willem Spicht, CCO at Rival Foods. Javier, do you maybe want to start off and tell us a bit more about your work?
Okay, at Cocos, what we do is to develop solutions for new products. We found that there were plenty of startups that just bought equipment from meat industry, and the result was that there were in the shelves a lot of different hamburgers from beans, from lentils, from tofu, but they were lacking other products. And we decided to start working on new devices, new technology, to be able to offer to the industry that produces new food these new machines. But then we realized that these machines are very linked to what you put on how you feed them. So what are the proportions of the ingredients? The product has to go through the process, and it has to maybe jellify or keep some temperature or pressure. So if you don't put the right proportions, you will not get a good end result. So that's something we have to also learn by ourselves. So we grow the team towards that. So now we are doing both machinery and formulations.
Thank you very much. Laura, what is your work about?
Hi, so first of all, thank you so much for having me and for inviting GEA.
Sorry to interrupt you, Laura. We have a bit of difficulties understanding you. Could you maybe shortly check your microphone, and maybe Willem, could you just jump in and tell us a bit more about your work?
Yeah, at Rival Foods, we create plant-based products using a minimum amount of ingredients and a minimum amount of processing with the technology we developed in-house called the shear cell technology. And basically this allows us to create very thick textures with a meat-like fiber. Most of it is based on soy, wheat, and pea protein. And it allows us to create whole cuts. So we're not really in the business of producing nuggets or burgers, but we're really looking at fillets and such.
Thank you very much, Willem, for this short introduction. Laura, do you want to give it another try?
I hope you can hear me better now.
It's still quite...
I'm really sorry. Can you hear me now?
Doesn't work out. But maybe just check, don't, never mind. I think we can jump in. We've now heard something about whole cuts, and maybe, Willem, I know you also prepared something you can show us. Maybe we can show what you're working with and how it looks like.
Yeah. I do see that Laura put on a headset, so maybe, maybe it's now better. I'll show something. Hold on, hold on. Here we go. Share this. So I hope you can see my screen now. Yeah, Nadine, this is good.
For me, it's now it's there. Yeah, great.
Okay, good. So here you can see on the right, you can see our latest machine. Basically, this is the one that we've developed over the last 5 years. The technology we use is called shear cell. This is something different than what you see standard now in the market. The most of the products you see out there will be made with high moisture extrusion, low moisture extrusion, texturized vegetable proteins, the sorts. We are doing something completely different. Basically, it works as a pressure cooker with a rotating part. And we use temperature and rotation to enable the deformation and alignment of proteins. And this creates a very fibrous texture. And it also creates a texture where the fibers go all the way along the product. So you actually mimic the fibrous texture of real meat. And this is something that's very important because if you understand high moisture extrusion, for instance, you know that the extrudate is always a very thin, it's a thinner product. Our product is 3 centimeters thick. Normally it would be around maybe 1, but mostly less. The point there is that you have to chop it up and then reform it into a product. And this works for burgers, it works for nuggets, it works for sausages, because you also, with the meat products, you also get let's say a processed product. But with whole cuts, this doesn't work because you want that fibrous texture and you want that bite to mimic the same thing as you would do with the animal version. And so we developed this at Wageningen University back in the day. Birgit, our CEO and founder, it was her PhD actually at the university. And she has brought it into an actual company in the past 5 years. And now we have our first production line up and running in the Netherlands, in the south of the Netherlands actually. And from there, we are already delivering first orders. So we're very happy with that. Just to give you also an idea about the clean label aspect, which we find very important here, we use a limited number of ingredients, and this allows us to create very high protein levels, relatively low salt levels, low fat levels. So you actually have basically the same nutritional value as the animal-derived product, sometimes slightly even improved. And our products come in 3 forms. So we create a poultry-like product, we create a red meat type of product, and a fish type of texture. And it's all textures actually. So when I say product, I mean mostly we're focused on texture. We can cut and shape in any form we like, but it's more that the texture is really dependent on the input of the machine, basically. And that's what we work on.
So before we start out, go over to Laura so she can introduce herself. So you put in different ingredients, but it's the same machine and you have a different outcome and a different texture for the different products.
Exactly. Yeah. So you can the most important aspect of that is the ratio between the proteins. But every ingredient has a role to play and has a significant influence, obviously. But also you have temperature, rotation, cooling that you can play with in order to create different types of texture. And when you go for chicken, you want a very fibrous, small fibrous type of texture. When you go for fish, you want a flaky, looser type of texture, more moist as well. And these are all things we can make from one machine. So that's also one of the, I think, advantages when you look at other production methods is you need to have multiple sort of machines down the line to actually create different types of products. And with our technology, you won't even have to actually.
Let's dive into that later. Also for, you know, I'm interested in whether you're not only having it for your company or maybe even thinking about having a patent you can sell. But Laura, I am so happy you are here too. Do you want to tell us a bit more about your work?
Yes. Can you hear me now? I apologize for these technical difficulties. So thank you so much for inviting me and inviting GEA as a company to this talk. So my name is Laura Pazitka, and for the last 6 years, I've been working on the development of cultivated meat in the lab of Professor Yaakov Nachmias at the Hebrew University in Jerusalem, in Israel. Kobi Nachmias is actually the founder of Believer Meats, which was formerly known as Future Meat Technologies, a company that is developing cultivated meat, mostly chicken at the moment, focusing on chicken. And so that was that study that I've done within my PhD encompasses 2 different aspects, and that's been like one focus of mine. And more recently, I have joined GEA in the business line of new food, which really encompasses all types of alternative proteins. So I'm very excited to hear from Willem and Javier about the plant-based solutions, because we also do deal with plant-based proteins with precision fermentation and cultivated meat. So really encompassing all 3. Now, in contrast to the other 2 guests here, or panelists on this show, GEA is not developing a protein product or process itself, but we want to enable our customers and clients to actually make their processes into a real product and to help them realize their vision for a product. So we supply machines, we supply equipment, engineering equipment, we supply systems. We can plan, design, and engineer and build these different production systems. And what you can actually see here in my background is a test center that we have in Hildesheim in Germany, equipped with various different upstream and downstream equipment, starting with bioreactors, homogenizers, all the way through filtration technologies, extrusion technologies, which is probably relevant here. Down to, filling, packaging, spray drying, everything that you can imagine, really pulling together from different types of industries in order to develop new systems that can support these new processes that we are about to develop, that our customers are about to develop in order to create new products.
That's a very broad range. I guess it's not that easy, to always have the expertise for every small bit and part. Like, that would be interesting to know. How do you cope with that? I have actually been in Hildesheim, which was very nice. It's very great surrounding there. But I know that you're, for example, working on perfusion technology. Do you want to tell us a bit more about that? And I know you've also prepared something you can share. I think on perfusion technology, is that right?
Right. So when we think about, especially about animal cell cultures, we quickly run into a problem when we want to create lots of biomass in a bioreactor. So cells produce waste products while they grow and expand and multiply. And these waste products become inhibiting at a certain point. So in order to remove these waste products and supply the cells with fresh nutrients in form of cell culture medium, we have to remove this or exchange the cell culture medium in the bioreactors. So one of the technologies that GEA came up with is really from the separation division. So GEA is a multinational, globally represented corporation that really consists of many different business lines and many different technologies that are incorporated in this company. And here in New Food, we have access to all of these different technologies that are represented in GEA. As I mentioned earlier, like, we can draw from the filtration, we can draw from separation, and the Kaitero in specific is a perfusion device that is based on separation, and that was developed specifically to support very sensitive animal cells that need to be provided with fresh medium. And I would just quickly share a picture of that. I hope it is visible, and really showing one example of a bioreactor that is being connected with the separation device. This is actually the separator, which we circulate the cells through, and which actually separates the cells from the cell culture media. So we have like a solid liquid separation. The liquid that is coming out, the cell culture media that is enriched with waste products, is being collected in a bag, and the cells are being circulated back into the bioreactor. So that's one of our innovations that we love to offer to our customers. So yes, we do want to support our customers in their processes they have developed, but we are also very happy to make tailor-made solutions and to really improve our processes, improve our equipment, and find solutions that are innovative that we can offer when we see that a specific trend or requirement or demand is coming up.
Maybe, for example, you could work together with Javier. I know you are also developing machinery, and I'm, of course, also really keen to know what you are doing actually, and maybe also how circularity could play a role, because that's actually for the food system all in all a very, very important area we all have to work on. That's what I found out in the last years. We're all talking about it, but not doing it. So maybe you want to show us your machinery and tell us a bit more about how it works.
Definitely. Thanks. Well, we started the company with mostly of the founders having background on 3D printing. But then we realized that we shouldn't apply the regular 3D printers, the X, Y, and Z Cartesian models that move and print things. We decided that was not the proper way to scale up. And we started to think, how can we do these new products if that printers can be adapted, if other technology can be used. So we have so far developed some final products for our customers, because we are B2B, and not all of them use these printers, but there are some that do. So we are using these printers, for example, to produce bacon. I'm going to show you how the printer looks like in one of the patents we filed from at the beginning. So this is how we thought a machine should start. So instead of having one nozzle that moves and make a lot of different shapes, we decided, let me hold it. So we decided that a device that fit into an array of 150 nozzles and decide which ones open and which one close, and eject or extrude some of the different ingredients, will form the different shapes such as this. Nowadays, what we have, the video is a bit slow. Okay. Nowadays, we have gone one step further, because, okay, maybe for certain products that could be, but it's quite complex. So can we simplify this? So one of the products we wanted to launch was plant-based bacon. And we found that many of the bacons in the market were just extruded with a coaxial extruder. So typically the ingredients in the fat and ingredients in the protein are usually the same. You are just changing coloring. And that didn't appeal us when the mouth experience was not that good. We were looking for a better experience where the fat is more tasty and different texture than the crust and so on. So we decided to modify this design that I am showing. And instead of that, we are combining these rows by combining these rows, simplifying the overall scheme, so we don't have that many pipes. And by doing that layering system, we end up with, oh, not this one. We end up with something like this, an end result. So a large block that comes out like that. And that's one of the machines that we are now adapting for our clients. We finished the first one last year. We put it on a client's facility. And now we are, well, they have been 1 year producing for retail, for large retail, such as Carrefour in Spain. And now we have modified a bit the machine to make it a bit more compact. I'm not releasing because we are now trying to update this patent that I showed. And we're now eager, of course, not only to use this machine for the bacon, but also for salmon, which is a similar approach, doing different layers on fat and protein. And of course, the good about this kind of system, well, either it is horizontal or vertical, we can tweak it, but then we can play with different ingredients. So we don't have to use only pea protein or only soy protein. We are exploring the, different ingredients. As you mentioned, circularity is one important thing. And well, I think that maybe as an introduction is there. Otherwise, I can be talking a lot.
No, that's it's great. And what I took for now is that you were kind of all like Willem, you and Javier, you're working on whole cuts. Is that an important product for the market, as we've already seen so many, you know, burgers and nuggets and stuff? Is this like the goal for future, to have the whole cut, to have a steak, like Planted has a steak? And what does that mean for the machinery also, and also for the ingredients we put in there? You've mentioned clean label. Clean label is like, everybody's talking about it, but actually, I mean, the processes are still there, and people kind of mix up these two issues. Yeah, that have been many questions.
That's true. I from our perspective, there's a couple of things going on, especially in, let's say, the processed meat section. So if you look at meat in general, also in the supermarket, for instance, you will have a whole cut and a processed product, right? And they're all in the same section, so to speak. And the plant-based for the past 5 or 6 years has been mainly focused only on the processed stuff, so the burgers, the sausages, and all that. And that's also because the current state-of-the-art technology, which is HME, basically lends itself very much for that sort of work. The problem even there is that a lot of ingredients are being used to create these products. So you get these really long ingredient lists with ingredients like methyl cellulose or other stuff, and it's stuff that people can't even pronounce, and when they see it on the label, they don't know what it is, and that creates also that narrative about highly processed, unhealthy foods, which has been also projected a lot on the plant-based industry. So there's a couple of things there. One is that the whole cut segment is untouched, so there's still room for growth there. So it's interesting to look into that market, because in the end, you want the whole category to be able to go plant-based, so to speak. So you need to also offer whole cuts. And actually, going from a whole cut back to a process is not that hard, because you can chop it up the same way. It's just how to create whole cuts with using a minimum amount of ingredients and healthy ingredients, so to speak, or not even not unhealthy ingredients. That's really the challenge, and there is an opportunity in the market for sure. And I think that's where most of the companies are now moving into that space, because there's still a lot of room there to go.
Also a danger maybe, because I know many people from the industry say that like early products have done nothing good for the market because they weren't that good, and people didn't, you know, they don't want to eat it again. So makes it even more important that texture and taste are really, really good.
Yeah.
How do you make sure the process is the right one? There are not that many ingredients and the product tastes really good, like before you put it out there, and then people won't buy it again because it's maybe not that tasty or stuff, like something like that.
Yeah, lots of testing and consumer panels, testing on clients, trying to figure out what is the preference of what people want. But in general, that's the only way to do it, right? You want to know if what you are making is actually responding to your clients and to your market. And I think there's a lot of ways to do that, but in general, testing it out on the public is the best way forward. And that, for instance, the CL is coming up. On those fairs, you will see a lot of companies testing out new products also to see what the reactions will be, right?
And what role does the technology play, Javi, for taste and for texture? You all said like you take different ingredients and it makes a different texture. So how important is good technology to have good texture, and how can we work on that? And what's the machinery of the future maybe to have the steak?
Well, I think we are learning about all the technologies and the different possibilities. There is not one single solution because there is no one product that will fit all of our tasting. So that's one thing we learned. We didn't want to focus on developing one product and try to sell it worldwide, because people in the UK will not like what people in Italy are liking. So that's in terms of taste. In terms of look and texture, maybe we are closer to on the different areas. But what I really see that will scale up things, and it's funny that we are talking on machinery, but I think I have a thought for us. So I see the same thing that happened with car industry, let's say, with especially domestic transport, which contributes highly to CO2 emissions. So there were a lot of initiatives to start to make, for example, commute to work with other people, car sharing, so trying to reduce the number of cars, or even in some cities, only odd plates go one day, and even plates other plates. So all these initiatives goes because the overall need is not is very clear to fight climate change and contamination. And I see that the actual scaling up of all the alternative proteins is when we realize all together, even governments, and start making actions, that the overall thing is that this is not, this is not a opinion that I like to reduce animals or just save them, which is fine. And for sure it's true. But underlying that is crucial that we work on sustainability. And that is what that is not the technology, but the mindset that will really speed things up. And there's still people discussing if climate change is real or not. We cannot have these conversations anymore. We have to embrace the new products. Of course, we have to be demanding. We need good products. We need tasty products. The saying that we cannot forbid people to take cars, we have to give them good solutions, like promoting electric cars. So this is the same. We have to promote new products that are tasty, clean, that fit in the price. So it's not only a matter of private investment and companies. Yeah, I think it's all the governments have to push this further. There have been tremendous research. If you see the history of food and you see the tremendous research in the last years, it's something we have to thank. But there is still some gap till mass consumers embrace these new products. We are still making new believers or new early adopters, let's say, but we have to change the mindset of the next generation. And I think it's happening. I think people, younger people especially, are looking back to the ingredient list, are thinking about what they consume, because it's the fuel for your body. So it's your health. It's not just the planet, it's yourself. So of course, you have to keep good things for the next generations, but you have to also take care of you. So that's the thing that I wanted to say.
Well, Javier, I totally agree. But I do think, you know, what you said is right. Like, it has to be healthy, tasty, and all that. And I think the current portfolio of products you would find in the market is in a lot of cases lacking. And I think the need is really there for companies like you and us, actually, and everybody involved in really creating novel technology, because the old ways of let's say texturizing are just not doing it for what we actually want to achieve. And I think that's a really that's a gap that we need to fill in a different way. And there are companies like yours come into play, because without companies innovating really on the back end, so not saying here's another recipe, here's a different thing that we know, really look at the beginning of the process, say, okay, where can we really make incremental changes? That really helps push products to a new level, and that will help consumer expectations as well.
Absolutely. And you're totally right. I mean, there's so many different issues we have to talk about, but I also think like the technology is at the heart of the system, because without scalability, and we have seen a market where we have cultivated products, for example, and the people say, yeah, we can like produce that amount, and then afterwards people working there said, no, actually we can only produce that amount. And so that's a real problem. Without the scalability, we can't go to the consumers. So they can't taste it. If they can't taste it, they don't know it's good. And that's like every part of the chain has to work. And one solution could be having maybe one working machine. And that's what I'm like, it's a bit of a black box. And GEA, for example, I don't know, when I was in Hildesheim, I saw the bioreactor, and I know it can do so many different things. Like, is this maybe, Laura, a solution that we have in future? And I guess everybody in technology would say, oh my God, what is she talking about? One machine? Because how can we bring together all the technology? But could that be like something that could change the market, to have one big machine, like Willem also said, where you can produce different things with, and maybe even at a certain scale?
So the bioreactor itself is definitely a very versatile tool, in the sense that kind of like knowing about bioreactor technology, such as GEA does, can enable you to really use it for multi-purpose functions. And actually, I'm really proud to say that here in Hildesheim, we do have bioreactors that we can use for these different types of cultures. So you don't have to use a whole new system. And I do think that I totally agree with the aforementioned that starting to be sustainable on the production scale, like where you start to produce the products, and not only expecting the consumers to implement these changes in their lifestyles, but to actually transform the industry is really also one of the focus points of GEA. And we had Mission 26 goals that we already reached in sustainability terms. Now we have Mission 30 goals. And I do think that it really, these are goals that, go from top to bottom, and we really try to implement them when we look at our machines and customers come with their processes, and we see how much water they use, how much water we have to use in these processes. It really gives us a chance to innovate at this lowest scale of improving the machines, improving the equipment, improving the process, making it more efficient in order to really be able to scale up. And then, of course, we also do try to simplify the processes and also the machinery, because we do want to enable our customers to sell their products for a reasonable price. I think that's one of the challenges in this new food industry, and I'm guessing the other panelists here probably face the same challenge, that we do draw from, at least in the cultivated meat industry and in biotechnology in general, we do draw from these two, I would say, poles of, on one hand, having fermentation, for example, where we use microorganisms to produce proteins or different products. And here we can scale up. I would love to say endlessly. Of course, there is a limit to scales, but we can scale up to huge systems and sell these products really cheap, comparatively cheap, while in the biopharmaceutical industry, we produce at smaller scales and at very high costs. So we try to balance these two poles, and I think simplicity, sustainability, and efficiency are kind of like these three pillars that I would base our technology on.
But Laura, I would like to hear from you, because in my opinion, or at least in my view, let's say the cell-based stuff in bioreactors, you're creating a ingredient. In fact, it's not the bioreactor doesn't structure anything. So what you still need in that sense, with precision fermentation and also with cell-based, that you still need a way to structure the product into something tangible and then edible, I would say, right? So what's your take on that? Like, what is then the steps, because you can't do that in one machine. Coming back to you, Nadine, I think that's going to be really hard if you're talking about texturizing and creating the ingredients itself in one go. That's going to be, I always see like you have ingredients as an input and you have a machine and that gives you an output, so to speak. And I think the cell-based stuff is more on the ingredient side actually than on the structuring side now.
I agree. I mean, at least at the current state of the art, I would say downstream processing is definitely very important in cultivated meat development. Yeah. And also currently the products that are many of the products and also the product that is already on the market in the US is a hybrid product. So we mix plant-based protein with the cell biomass that is produced in the bioreactors. You could think about, incorporating other ingredients that would contribute at least to the texture of a cultivated meat by adding scaffolds, microcarriers, whatever. There are approaches as such out there in science. But again, also for the downstream, just similar to the bioreactor process itself, when we think about perfusion, okay, maybe there is some way to incorporate, like to connect different modules, make them one. And I think also for the downstream, there are ways to simplify the downstream and to improve the downstream to make it smaller, more compact, more efficient. So I think the same ideas go for each step of the process.
Thank you.
What I now think when I listen to all your solutions is like, and my big idea of having one machine, if downstream, like how could we maybe combine the knowledge we have in these different companies, and if we put together all of these people in one room for 1 week and they, bring together all their knowledge, could we maybe develop something even better? I know this is not like a capitalist view and we all need our patents, but we do see the hybrid products out there, and maybe we could have you doing the cell, then they somehow come into your machine and are printed into a bacon, and that, I don't know, like how could we combine this? And what I also wanted to know from Willem and Javier, maybe which role does artificial intelligence maybe also play here? Is that anything you're working with?
Well, we're just starting. We felt that it was necessary to jump in, not to stay apart. What we are trying is, well, we have done a lot of formulations. Some of them had more success than others. But what we are trying is to analyze all those outputs, what things work better and why, and give them some values and try to fit them with an algorithm to try to predict new outcomes from new protein sources or different gelling agents. So we are trying to fit how clean we can get, what are the price that we can get with putting this, putting that. So for covering costs, for implementing new ingredients, and even you were mentioning the hybrid. I think we have to underline, well, I wanted to underline that I really see really important the potential of these blended products, of hybrid products, mostly in terms of marketing penetration. So we have already seen some, and also some reluctancy from countries of culture cells, which is crazy, in my opinion. But blended products would really make these cultivated cells fit faster in terms of cost, and also in terms of entering into retail as soon as possible, not just in high Michelin stars that we can see from time to time, and that we see the news, but nobody can go there to try these new products.
Yeah, I agree with Javier. Is that we actually have been approached a couple of times already by cell-based meat companies because of the fact that they're looking for different ways to structure their let's say protein, so to speak. And I think, especially if you look at specifics like fat, for instance, is very interesting. If you can mimic animal fat, which gives the same flavor and has the same use as you would have in, for instance, a steak. That could be something very interesting to work with if you combine that then with the plant-based basic structure, so to speak. So I think there's cooperation going on behind the scenes, Nadine. It's not like we're all getting in a big room, because in the end we need our patents because we need to raise money to grow, and that's the way the game works. I wish it was otherwise, but I think that's a given. And to your second question, I remind me again. There was the
artificial intelligence.
Yeah. For us, I've seen some very interesting stuff but that's more on the commercial side, about consumer preferences and gauging the markets, basically using AI to see what consumers are actually doing at the moment. So in a sort of a real-time situation, what you always see if you look at the data, so it's Nielsen data or any other data on consumer behavior, it's always looking in the past, because in a way, it's always been, it already happened, so to speak. And what you can do now is actually go almost via social media into real-time interaction with what are people actually putting on their plates, what are they taking pictures of, so you can get a real bigger visual on what's going on with consumers and their food habits. This is really interesting, I think. And on the other part, I believe, especially for the ingredient side, there's a lot. In that sense, we only scratch the surface. So AI can probably help us uncover a lot of new ingredients and proteins that we haven't even considered using yet at some point. So, but we don't use it a lot now. We also a bit afraid of, we don't know where the data ends up. And since everything is so, let's say, sensitive, we don't want to just put everything on somebody else's server, so to speak.
So now we have like around about 5 minutes left, and I want to thank Vera at this point, who is putting together a mind map again with all relevant points we've discussed today. And what I always like to have in the end is like a bit of a vision maybe for the future. And my personal interest a bit also, is there maybe something, now we've seen plant-based, we've talked about fermentation, cultivation. Is there something going out there in the tech area we didn't even talk about, we don't know about? You can give us a hint on? No one wants to tell their secret.
Tough one. No, listen, I'm really looking forward to seeing what happens with cell-based and precision fermentation in terms of the ingredients that are come out, and if we can combine those with plant-based and really create a next level type of products. And I think that's still a ways away, but we're getting there. And I think that's the main thing on the horizon now. And further than that, I haven't seen anything crazy so far, but
no, I'm always thinking about molecular farming and stuff, you know, like you take processes and put them somewhere else. So maybe, you know.
Yeah.
So Javier, you wanted to.
Yeah, I'm curious to see if insects will take its place. As far as I know, they are quite sustainable, but it's still quite a matter of education if we can take a protein out of them and implement in our chain. If they are not vegan, if they are, so there are many issues there, but I think they could be one of the sources.
Absolutely, but then we're also going right into culture. Laura, what's your vision of the future?
So just as a short kind of background to it, this summer, my professor, or together with my professor Kobi Nachmias and Believer Meats, we published a study in Nature Foods that is giving an economical assessment of cultivated meat production, or cultivated chicken production in particular. So I think drawn from that, and also based on David Humbert's study that was published in 2021 on, really the economical viability of cultivated meat, I think now all eyes are on making these cultures more efficient in terms of culture media use. So again, formulation of culture media, and of course, how can we possibly recycle cultivated, spent culture media is something that I think many eyes are on, and many people are working on. Many small labs, big labs all around the world, and different universities and research institutes are on it. I think that's going to be something very exciting.
Definitely. Cultivated meat or cultivated products, cellular agriculture is going to be our next episode is going to be about that, actually. But for now, I want to thank you guys for sharing some of your thoughts, some sites on your technology, and for all of the insights. All you people out there, thank you for being here with us. I hope we could update you. And save the date, 21st of November. We're going to have our next talk on cultivated products. Thank you and have a nice evening.